Let's do a problem from your lab assignment, section 5.5. They want us to evaluate the indefinite integral. Here we have the integral of cosine, and we have a pi divided by x to the 20th, and that whole thing is divided by x to the 21st. So we want to decide what to choose for u, and we have to remember that the derivative of u is going to be the derivative of that function dx, and we want to look for things in common. So if we can rewrite this expression as just the cosine of pi divided by x to the 20th times, this is in the denominator, x to the 21st is in the denominator, so we can say x to the, or 1 divided by x to the 21st power. We can also say x to the negative 21st power. That would also work. And that's going to be interesting for us because the derivative of pi times x to the 20th is going to be pi times, and the derivative of x 1 over x to the 20th, that's going to be negative 20 times x to the, you have to subtract 1 to the power, so this is negative 20. You subtract 1, that's going to be negative 21. Now this probably looks a little complicated. Oops, this is a power, sorry. But we have to maybe look at this thing. Maybe we'll do this off to the side. If we take a look at d dx of pi, now instead of divide by 20, let's write it as x raised to the negative 20. And so the derivative of that is going to be, there's a pi out here, and then the derivative of the power rule is going to be negative 20 times x to the negative 21, because we have to subtract 1 to the power. Alright, so let's rewrite this a little bit, make it look a little bit nicer. So this is going to be negative 20 pi, negative 20 pi, and then x to the negative 21 is like saying divided by x to the positive 21. So we'll see that this is part of the denominator, which is exactly what we were looking for. And the powers are a little tricky because you're dealing with powers in a denominator, so just be careful with that. So with a proper u substitution, we have du is going to be equal to this thing. Now if that's what du is equal to, we want to replace this dx with that. Alright, so what is missing here? Let's actually, maybe it would be better if we write all this stuff out. So du is equal to, according to what they have here, negative, this is 20 pi divided by x to the 21 power in the denominator times dx. So let's move things around. Let's take this negative 20 out here. So negative 20 pi times 1 over x to the 21st power times dx. And so this is exactly what we're trying to replace here. And we can just imagine taking this, taking this negative 20 pi and dividing it by this here. So our expression then will have 1 over x to the 21 dx can get replaced with du over negative 1 over 20. So 1 over 20 pi negative. And then the du is going to be off to the side, so we can split that up. All right. negative 1 over 20 pi is just a constant that we can bring outside of the integral. And if we do that, all we have left is the cosine of u du. So remember that the cosine, the integral of a cosine is a positive sign. So we'll put a positive sign u here because it's a u variable. And then converting it back into x. Oops, let's not forget about our constant out in front here. And the constant is negative 1 divided by 20 pi as a constant. So it's essentially this whole thing, except instead of a u, we have to figure out what was u equal to. U was equal to pi divided by x to the 20th power. So it's going to be the sine of pi divided by x to the 20th power times negative 1 over 20 pi. And, of course, the plus c. Okay, let's check that, and hopefully it's correct. Okay, it looks correct. We got everything complete. If you take a look at what they wrote up, it's slightly different from the way we wrote it, but, you know, it's all equivalent. So we're good. I hope that helps.